everyone, and welcome to Middle Smart. Today, we're diving into the fascinating world of slime. You mix a few ordinary ingredients together, and boom! You've got this gooey, stretchy, mesmerizing substance. But have you ever wondered what's happening at a molecular level when you make slime? Get ready to put on your thinking caps and grab your safety goggles because we're about to unravel the science behind this gooey wonder. Okay, slime enthusiasts, let's start with a classic, borax slime. Slime is all about something called polymers. Polymers are long, chain-like molecules made up of repeating units like a chain of paper clips. In our borax slime, the polymer is polyvinyl acetate, the scientific name for white glue. White glue by itself is sticky and smooth, but we want to make it slimy. That's where borax comes in. Borax, or sodium borate, acts like a cross-linker. Imagine those paper clips again. If you start linking them together, you create a stronger structure. Borax links the polyvinyl acetate molecules in the glue, creating a network of interconnected molecules. This cross-linking gives slime its signature stretchiness and gooiness. When you mix borax with water, it forms borate ions. These ions interact with the polyvinyl acetate molecules, forming bonds that link the polymer chains together. The water in our recipe helps the borax dissolve and disperse evenly, providing a medium for those borate ions to move around and interact with the glue molecules. So when you're squishing and stretching your borax slime, you're witnessing the amazing power of polymers and cross-linking in action. Alright, slime aficionados, let's explore another type of slime, glue slime. This time, we're using activators. Just like our borax slime, glue slime relies on the magic of polymers. We're still using polyvinyl acetate glue as our base, but instead of borax, we're using activators like baking soda, contact lens solution, and liquid starch. Baking soda, or sodium bicarbonate, acts as a cross-linker, releasing ions that interact with the polyvinyl acetate molecules in the glue. Contact lens solution contains boric acid, a close relative of borax, which also acts as a cross-linker. Liquid starch works similarly, with starch molecules interacting with the polyvinyl acetate molecules to form a network of interconnected polymers. The beauty of glue slime is that you can experiment with different activators and see how they affect the properties of your slime. Some activators might create a thicker, more rubbery slime, while others might result in a thinner, more flowing slime. So the next time you whip up a batch of glue slime, remember that you're conducting a fascinating chemistry experiment right in your own home. Well, that was a gooey good time. We've explored the fascinating world of slime, from the classic borax recipe to the activator-powered glue slime. Remember, it's all about those amazing polymers and the power of cross-linking. So the next time you find yourself with a handful of slime, take a moment to appreciate the science behind this mesmerizing substance. Thanks for joining me today on Middle Smart. See you next time.